Welcome to qnawire.
In this case, we're going to have acetic acid, and we're going to have different mixtures that contain acetic acid plus acetates on different concentration. In this case, specifically is sodium acetate, but we only care about the concentration of the acetate ion that we're going to have. So the information that is given to us is the value for Ka for acetic acid, that is 1.8 times 10 to the minus 5. With this, what we can get is the value for pKa, which is equal to minus the logarithm of Ka. In this case, the value for pKa is going to be equal to 4.745. So for all of the different solutions, what we're going to be able to do is employ the Henderson-Hasselbalch equation for the calculation of pH. So for solution A, we're going to have 0.1 molar acetic acid plus 0.1 molar sodium acetate. Henderson-Hasselbalch equation tells us that pH is equal to the pKa plus the logarithm of the concentration of the conjugate base, in this case would be the acetate, minus ion divided by the concentration of the acetic acid. In this case, for simplifying notation a little bit, the way that I'm going to write down this concentration is going to be A minus for the acetate ion and HA for the acetic acid. So in this case, concentrations are equal. pH is equal to pKa, that is 4.745, plus logarithm of 0.1 divided by 0.1 molar. This is equal to 4.745. Remember that logarithm of 1 is equal to 0, and whenever we have the same concentrations of the acid and its conjugate base, the pH is going to be equal to the pKa. Now let's look what happens for solution B. For solution B, we're going to have 0.1 molar of acetic acid and 0.05 molar of the acetate ion. So now our equation becomes 4.745 plus logarithm. The acetate is going to be 0.05 divided by 0.01. Sorry, 0.1. I added extra 0 here just by accident. Divided by 0.1 molar. The result for solution B is going to be a pH equal to 4.444. In this case, since we have more of the acid than we have of the conjugate base, as you can see from the concentrations, that means that the pH is going to be lower than the pKa. So in that way, we can always check if we put the correct signs into our equations. And finally, for solution C, we're going to have 0.05 molar of acetic acid plus 0.1 molar of the sodium acetate. So now we're going to get a more basic pH because we have more of the conjugate base. pH is going to be equal to 4.745 plus the logarithm of the concentrations. In this case, acetate is 0.1 molar divided by 0.05 molar of the acetic acid. This gives a value of pH of 5.046. 5.046. So with that, it would be all. Thank you very much and have a good one.